Hey guys, today we're going to talk about radian measuring just found in section 4.1, part 1. Our objective is to describe angles. So just a little bit of
first start by talking about history.
Trigonometry means measurement of triangles.
So trigonometry
initially
means
it dealt with
measurement
relationships
of
with
angles.
sides.
Initially
It dealt with relationships with sides. That's supposed to say and angles of triangles that was used in the development of astronomy, navigation, and surveying. Later in the 17th century, with the development of calculus, the applications of trig expanded to physical phenomena involving rotations and vibrations such as sound waves, light rays, planetary orbits, vibrating strings, pendulums, and orbits of atomic particles. So in a lot of ways, trigonometry is kind of all around us in different forms. So a little bit of vocabulary. So as an angle is determined by rotating a ray about its endpoint. If you remember a ray from geometry, we're talking about that same ray. The starting position of the ray is the initial side of the angle, and the position after the rotation is the terminal side. So the way we measure it is from the initial side to the terminal side. The endpoint of the ray is the vertex of the angle, usually centered at the origin. The initial side typically coincides with the positive x-axis. So if we look at the vertex and initial and terminal sides, again, if you look at figure A, where you see the red arrow, that's how we would measure. We would measure from the initial side to the terminal side. And that's just, for figure A, that's just some angle that's kind of out in free in space. But angle B shows that this angle is actually on a coordinate plane. And when we measure it on a coordinate plane, the initial side is always the positive x-axis. So we start from the positive x-axis until wherever it stops. So a little bit more vocabulary. So it says positive angles are generated by counterclockwise rotation and negative angles by clockwise rotation. So let's note that alpha and beta have the same initial and terminal sides, making them coterminal angles. So look at the first figure, 4.2. So again, we know that the positive x-axis is the initial side. So when it goes counterclockwise, it becomes a positive angle. And if we go clockwise, it makes it negative. So going clockwise is actually opposite of what we think, because when we think about a regular clock, we know that time goes in that direction and time is positive. However, when we talk about angles and degrees, in this case, it would be negative angles. Okay. And if you look at figure 4.3, the angle alpha and the angle beta, they start and end in the same spot. However, angle alpha is some positive angle and angle beta is some negative angle. However, because they end in the exact same spot, they're considered coterminal. Same thing on that very last figure to the right. Again, angle A and angle beta, even though angle beta has gone fully around, and we'll call that in a moment a full revolution, but either way, because they begin and end in the same location, no matter how many times it has done a revolution, then it is still considered a coterminal angle. So let's talk about radian measures. So one way to measure angles is in radians. So we define a radian, or to define a radian, you can use a central angle of a circle, one whose vertex is at the center of the circle. So if you look at the figure, we call our central angle on this figure theta, and theta is going to represent 1 radian. And the arc length is the radius. And we know radius, right? We know radius is half the diameter. So for us, that radius is kind of like our initial and our terminal side, except we actually know what the true length is. Again, this is supposed to say more about radian measures, not supposed to say radiant. But anyway, so it says the circumference of a circle, so 2 pi r, circumference of a circle is 1 full revolution. So that is equal to full revolution times pi times r. So circumference and 1 full revolution are the same. So 2 pi radians is 360 degrees. 1 pi radian is considered 180 degrees. Pi over 2 radians, or just half of pi, is considered 90 degrees. And because 2 pi is about 6.28, there's a little over 6 radians in a full circle. So essentially what you need to know is that 2 pi is a full 360, okay? So pi itself, if I have to take 1 pi, that means I have to take it in half. And that part is considered 180 degrees. So a straight line is considered 180 degrees. And then half of pi, we have to cut that in half. So half of 180 is 90. And then we start from there, we kind of start making everything fractions. So the unit circle is all about fractions and a lot of degrees and angles. But the more that we practice this, the more that we'll understand it. All right, so talking about quadrants. So it says this figure shows which angles between 0 and 2 pi lie in each of the 4 quadrants. Note that angles between 0 and pi over 2 are acute, and we know that because angles between 0 and 90 degrees are considered acute angles. And angles between pi over 2 and pi are obtuse because pi over 2, again, is 90 degrees and pi is 180, so anything between 90 and 180 degrees would be considered obtuse. Something that I often do is I switch between radians and degrees, especially when we're first learning it, because we are so used to degrees from geometry, but we're not very used to radians. So I will interchange for a while until we get used to being able to recognize certain radians as degrees. So again, if we're looking at this, it's basically showing that the angles from 0 to pi over 2 is considered quadrant 1. Then from pi over 2 to pi, that's considered quadrant 2. Remember, that's anything from 90 to 180 degrees. Then anything from 180 to 270 or pi to 3 pi over 2 is considered quadrant 3. And then anything from 3 pi over 2 to 2 pi, which by the way is 270 back up to 360, is considered quadrant 4. So any angle we'll know comes in between these. And remember, the terminal or the initial side is always the positive x-axis. So again, something that's considered quadrant 1 would fall here, right? Something that is considered quadrant 2 would fall somewhere over here. Something that is considered quadrant 3 would fall over here, so all the way from the terminal side or the initial side. And something that is considered quadrant 4 is something that's all the way around. So really large, almost full revolution. All right, so coterminal angles, not terminus. Again, I don't know why I have so many typos, but I'm going to go ahead and change that. That's coterminal. Coterminal. So remember, 2 sides are coterminal. Oh my goodness. Sorry, they're coterminal if they have the same initial and terminal sides. For example, 0 and 2 pi are coterminal. You can find an angle that is coterminal by adding or subtracting 2 pi, which is 1 revolution. So what we're about to start doing is figuring out how to find coterminal angles. And again, the way we do that is by simply adding or subtracting 2 pi. If we want to find a positive coterminal angle, then we will add 2 pi. If we want to find a negative coterminal, then we will subtract 2 pi. So in example 1, it says for the positive angle 13 pi over 6, subtract 2 pi to obtain a coterminal angle. And again, technically, this would be a negative coterminal angle. So let's go ahead and do that. So 13 pi over 6. We want to subtract 2 pi. So if we subtract 2 pi, we need a common denominator. Right now it's 2 pi over 1. So to get a common denominator, I'm going to multiply by 6 over 6. So this becomes 13 pi over 6 minus 12 pi over 6, which gives us pi over 6. Okay. If I were to sketch that, by the way, if I were to sketch that, oh, that's really bad. 13 pi over 6 is honestly a little over a full revolution. And I'm just showing you that, not that you need to know that right now. But 13 pi over 6 technically would have done something fully around that way. And pi over 6 is just from the initial side up to this point. So just this portion right here. And so that's the sketching. At some point, a little, and very, very, very soon, we will get to like how I know where these angles are. But right now, we're just, really, I just want you to just find the coterminal angles. All right, so it says for the negative angle, negative 2 pi over 3, we're going to add 2 pi to obtain a coterminal angle. So negative 2 pi over 3. If I add 2 pi, again, I need to find a common denominator because it's currently over 1. So I'm going to multiply by 3 over 3. And that's going to give me negative 2 pi over 3 plus 6 pi over 3. That's going to leave me with 4 pi over 3. So that makes 4 pi over 3 and negative 2 pi over 3 coterminal. They are both coterminal. And again, if I sketch that, 4 pi over 3 is over here. So that means that negative 2 pi over 3 would have been in the opposite direction. Again, negative would have been in that direction. All right, let's keep going. So we're going to practice again. So it says for the positive angle 3 pi over 4, subtract 2 pi to obtain a coterminal angle. So 3 pi over 4. If we subtract 2 pi, again, we need a common denominator. That common denominator is 4, so we're going to multiply by 4 over 4. So this is 3 pi over 4 minus 8 pi over 4. That's going to give you negative 5 pi over 4. So the coterminal angle with 3 pi over 4 is negative 5 pi over 4. All right, so complementary and supplementary angles. So two positive angles, alpha and beta, are complementary if their sum is pi over 2. Two positive angles are supplementary if their sum is pi. So let's talk about that. So complementary angles, we know complementary angles typically are between 0 degrees and 90 degrees. And remember, for us right now, because we're still trying to get used to the vocabulary and the numbers, what that means is that would be from 0 to pi over 2. So essentially what that means is if I have some angle alpha, okay, and then I have another angle within here. So I really hate to draw it like this, but just imagine that it's from here to here, and this is considered beta. As long as the two of them, alpha plus beta, if they equal 90 degrees, then that's considered complementary, okay? In the same respect, something is considered supplementary if it goes from 0 degrees to 180 degrees. Again, with knowing our information about radians, that would be from 0 to pi. So again, if I had some radian or some angle alpha, and again I'm measuring it from here to here, and then I have some angle beta, whatever it is, like maybe it's from here to here, again alpha plus beta would equal 180 degrees or pi, whichever. Okay, so let's try and find our complementary and supplementary angles. In example 2, we're asked to find the complementary and supplementary angles. So it says, if possible, find the complement and supplement of 2 pi over 5. All right, so to find the complement and supplement of 2 pi over 5, let's think about it logically. So the complement would be, for example, 90 degrees, and I wish it would write correctly, 90 degrees minus the angle that we've been given must equal the complement. Okay, so the one that we're trying to find. However, since we're not in degrees, but we're in radians, I need to change 90 degrees to pi over 2. Because remember, that is what 90 degrees is as a radian. So pi over 2 minus this 2 pi over 5 will give us the complementary angle. Well, currently I need a common denominator, and 2 and 5 are not the same. So a common denominator of 2 and 5 would be 10. So I'm going to multiply this first fraction by 5 over 5 and the second fraction by 2 over 2. All right. So those equivalent fractions would be 5 pi over 10 minus 4 pi over 10. So the complementary angle is going to be just pi over 10. So in other words, 2 pi over 5 plus pi over 10 will equal pi over 2 or 90 degrees. So that is the complementary angle. Again, using logic, to find the supplement, I would do 180 degrees minus the angle, and that would equal the supplement. Okay, and 180 degrees is pi, if we want to talk in radians. So pi minus 2 pi over 5. Again, we need a common denominator right now. Pi is over 1, so if I multiply by 5 over 5, that would give me 5 pi over 5 minus 2 pi over 5, which equals 3 pi over 5. And that makes sense. So 3 pi over 5 plus 2 pi over 5 would equal 180 degrees or just pi. And sometimes it's not always possible to find a complement. And the reason why I wouldn't be able to find a complement is because the angle given to you is already greater than 90 degrees. So obviously there's no way that you can find a complement to it because it's already considered obtuse. All right, so in try number 2, it says, if possible, find the complement and supplement of 4 pi over 5. So again, what we will do is for the complement, remember it has to add up to pi over 2. And for the supplement, it has to add up to pi. So for 4 pi over 5, I'm going to do pi over 2 minus 4 pi over 5. This is to find the complement. Okay, we need a common denominator again. So this is, I have to multiply by 5 on this one, and I need to multiply by 2 on this one. This one will give me 5 pi over 10 minus 8 pi over 10. Guys, if I run into a situation where I get a negative, like I get here, negative 3 pi over 10, what that tells me is that 4 pi over 5 is already obtuse. In other words, it's already greater than 90 degrees, so there is no complement. Okay, but the supplement I should be able to find. So if I do pi minus 4 pi over 5, again, I need a common denominator, so I'm going to multiply by 5 over 5. That's going to give me 5 pi over 5 minus 4 pi over 5, which gives me pi over 5. So pi over 5 is a supplement to 4 pi over 5, and we're done. Guys, if you have any questions, please be sure to come see me for tutoring.